All right, so yeah, what we're looking at today are what are called rational expressions. And first mentions there what rational expressions are. It's basically just a polynomial divided by another polynomial. It may be as simple as 1 over x. But, yeah, it mentions a couple of others, fairly simple ones. We'll look at some more complicated ones. But, yeah, so it's basically a fraction, polynomial fraction, fraction with variables, is what we mean by that. B points out, yeah, if you evaluate, let's say this one, evaluate for x equals 5. Yeah, same. Same thing as we always do. That x can be any number. Well, there's an exception that we'll talk about in just a second, but yeah, we can plug in any number, and so if it's evaluate for x equals 5, that just means you plug in x to be 5. So you got 5 plus 1 over 5 plus 3, pretty simple there. So you got 6 over 8, which is reduces to 3/4. Yeah, so it's just, you can plug in any number, except there is a restriction. So C mentions there the restriction is that the denominator can't be 0 because, well, yeah, if you have a denominator 0, that's dividing by 0, and try that on your calculator, that isn't going to work out. So you can't divide by 0, so the denominator can't be 0, and so the restriction on this one, x plus 1 over x plus 3, keep going with that, is that x cannot be -3. So we plug in x to be 5, we could plug in any other number except the denominator, what makes the denominator 0. And so we'll talk probably more about that restriction, type of restriction later on, but you did just mention it in this one. All right, so on to D. This is where we kind of get into the work that we want to do for this assignment. All right, to simplify a rational expression, factor the numerator and the denominator, then cancel common factors. Okay, so yeah, there's to reduce a rational expression, you have to reduce factors, common factors. So that is a big point here. So let me mention a couple before we get into those examples. This isn't on the page there, but let's just start with this one. So yeah, just like regular fractions, which we kind of got one here, with 15 over 10, we reduce those by the common factor. So 15 and 10 have a common factor of
2/3 or
5. They have a common factor of 5, yeah. So we reduce them, those by 5. And so that gives me a 3 on the top and a 2 on the bottom. Now, same thing on these x's. They have a common factor of x, so if I take out an x there, that just goes away, and then what happens to this one? Well, you take out an x, that leaves you an x squared, doesn't it? And so that's what we're pointing out. You have to take out those common factors, and so you're left with 3 over 2x squared. That's one way to do it. I guess there's others, but that's kind of what we're looking to cancel those common factors that the top and the bottom have. Now, might want to make this note. If we have binomials, which means two terms, x plus something, x minus something, for example, you can only cancel binomial factors that are exactly alike. So you can only cancel binomial factors that are exactly alike. And I mean exactly, okay? That's the deal on binomial factors. So if I have, let's say this one's already factored, this rational expression, we've already got it factored. You got x plus 4 times x minus 3 on the top. And then we have x plus 3, x plus 4 on the bottom. Already factored out for us. Okay? So what I'm saying here is we can only cancel what? The x plus 4s cancel. Those are exactly alike. So those are common factors, top and bottom. But what about the x minus 3, x plus 3? Not exactly alike, are they? Yeah, they're very close. But you can't cancel those. Because they're not exactly alike. That's just the way those binomials are going to work there. Now, one, I guess you might say, exception to that, but it's not really an exception, if you think about it. All right, so those aren't exactly alike. One's x minus 7, one's 7 minus x. However, one is just the flip-flop of the other, if you will.
X plus 7?
Well, here's what we can do on that, and that's what we're going to get into here. Turns out that what we can do sometimes is factor things, and so let me just show you here what happens when we have an x minus 7, 7 minus x, or something similar. If we factor a -1, and let's just do it off the bottom there. So factor it out, so that just all that does is change that to a -7 and that to a plus x. Do you notice now, I mean, it's turned around, but do you notice now that you've got x minus 7, and then this is also x minus 7, if we might as well just write it that way. Now they do match. And so we wind up with 1 over -1, which is just -1, okay? And so what I would say is if we have that scenario again, let's just cut to the chase and say, well, in that case, we can cancel, and it becomes -1. So if I have something similar, x minus 3 over 3 minus x, those will cancel, and they will cancel to be -1. So that, the one exception, which is not really exception, but that doesn't appear to be exactly alike, but it does cancel, it just cancels to be -1, okay? So we'll use that little fact along the way. All right, so let's get into the examples there on page 10, kind of middle of the page, on D. This is example, first example on D. It's got 2x plus 10 over 3x plus 15. Okay, so yeah, as noted above there, to be able to cancel here, we've got to factor first. All right, and so that's, you can factor, that's the rule that we're going to live by here. Factor this guy first. All right, so if we factor 2x plus 10, that just has a common factor of 2, so we're just going to pull out a 2, and that'll leave me x plus 5 here. On the bottom, I can factor off a 3, so that'll make it 3 times x plus 5 right there. And so sure enough, we do have that common factor binomial factors that are exactly alike, those can cancel out, so ta-da. We do have 2/3 as the reduced form of this example. Is that okay? Question or concern? All right, so the second example, we got x squared minus 5x plus 6. That's divided by 9 minus x squared, okay? So we haven't done any factoring of this sort yet, but yeah, so we factor these. Guys first, because yeah, I said binomials you can only cancel if they're exactly alike. Well, the same thing with trinomials, right? We got a trinomial, 1, 2, 3, trinomial, and then we got a binomial. Neither one of those match up, and we can't just go canceling things because it's got to be factors. We don't have any factors yet, and so yeah, we factor the top, and so that trinomial factors into a binomial. You got x squared, x and x, 6 in the middle, -5. So that's -3 and -2 to get that one. And then 9 minus x squared, well, that's a difference of squares. That's what I call it. And that factors into a binomial. 9's 3 and 3. Minus x squared is minus x and plus x. Now that we've got it factored, all right, so yeah, so here is the thing I was talking about. We don't have an exact match, but what do we have here? Well, we've got x minus 3, 3 minus x, and what happened there? In that case, those cancel out, but they come out to be, instead of 1, it's essentially when you cancel them out, they're 1, but in that case, it's -1. And so the others, of course, don't match, and so, yeah, we're going to wind up with, let's just call it negative x minus 2 on top, and then let's write that as x plus 3. 3 plus x would be okay, but something like that. You could write it in the front. I can see it that way too. Is that okay? All right. Now, let's go to Roman numeral 19. Multiplying and dividing. Page 10. All right, so multiplying, it says could multiply straight across, but normally we factor and then cancel common factors and then write as one rational expression. Okay. Yeah, so let me give you an example here. It doesn't have an example there on A, but let me give you an example. So let's go 5x squared over 7y cubed times 42 y to the 5th over 20x to the 6th. So yeah, when we have these, of course, I guess technically it is factoring, but usually we don't factor those out and cancel. We just cancel, don't we? All right. So what can we cancel here? Well, that's what he was saying. We can cross cancel, which just means the denominator, let's do the numerator over here and denominator over here, because essentially this is all going to be one numerator, this is all going to be one denominator, but let's just look at canceling. That's what he means by cross canceling there. What can I do to that 5 and the 20? Well, they both have common factors of 5, so pull out that or cancel that out. 7 into the 42, we cancel by 7s. 1 and 6 there. With me? All right, then what about the x's? Well, same thing. You got an x squared, so we can cancel it out with that x to the 6th. That'll leave me an x to the 4th on the bottom because basically it takes those two out. And And then the same thing on the y's. The y's, you got a y cubed on the bottom, so you can wipe that one out, and then y cubed out of that one, so that'll leave me y squared. Basically subtracting, leaving that. So what have we got left on the top? Looks like it just has 6y squared, doesn't it? And then 4x to the fourth there. So that's an example there. There's a couple of them in the homework similar to that. B, when dividing, don't forget to reciprocate, which in simpler terms just means flip the second fraction and then turn it into multiply. So let me do an example there. So let's say we've got 8x squared over 9 divided by x over 27. Yeah, so dividing fractions, remember, you divide fractions, basically what you do is you just flip the second one and just multiply it. And that'll give us then, so we flip that one and change that to multiply. And so now we just have the same problem we had before. Just look at canceling. So this 9, cancel into that 27, goes 3 times. What else? This x can go into this x squared, leave me an x to the first on the top. And like I said, when I'm crossing these out, those just are leaving me 1s there. And so what do I have on top? Well, I have 8x times 3, so that's 24x. And then on the bottom, I just have, they all canceled out, so it's just 1, and you don't have to write the denominator 1, so this one's just 24x. Yes? So far, so good. All right, so on to page 11 here. All right, so now the example, top of page 11. We have x squared minus 4 over 4 minus 2x times 10x over x squared plus 6x plus 8. All right, so this is just like we had on the previous part. 18 there, we were on. Roman numeral 18. When we've got binomials or trinomials, you can only cancel factors. And so guess what? We need to factor. Factor first. You know, the phrase of the day. If you got something that factors, factor it first. All right. So we've got several things that factor. We've got this x squared minus 4. Well, that's a difference of squares. That's x minus 2 times x plus 2. Go with the bottom of that. That just has a common factor, so you just pull out a 2. Common factor of 2, so that'll leave me 2 minus x. That one. Of course, the 10x, we don't factor it. X squared plus 6x plus 8, well, do our factoring thing. That factors into 2 binomials. X and x for x squared. 8 with 6 in the middle is 4 and 2. Gives us 6 in the middle. Now we've got times, and so that's where we're saying, just like we did on A over here, we can do some cross canceling or even canceling on the same part, but what can we cancel here? The x plus 2's, got one on top, one on the bottom over here. Now we've got a 2 and a 10, so we can cancel that 2 into that 10. Leave me 5 on the top there. That cancels that to 1. What else? Well, there's our old x minus 2, 2 minus x. It's not the same, but it's one's just the reverse of the other with the minus. What does that cancel to?
To a negative 1.
That's a negative 1, yeah. It's not 1, it's negative 1. So next best thing, I guess. And that's it, isn't it? So you got negative 1 times 5 times x, so that's negative 5x on top. What's left? On the bottom, just x plus 4. And that's where we stop. Because again, to cancel a binomial, you have to have an exact likeness on the top. There is not an x plus 4 on the top. What I'm saying is you can't cancel those x's. Because you got to cancel that whole binomial if you're going to cancel it at all. All right? Now the second example, we have x squared plus 6x plus 8 divided by x squared minus 16 divided by x squared minus 7x plus 12 divided by x squared minus 9. All right. So this one, let's go ahead and do this first. Just like we did on this one, what does the divide mean?
To change it?
Flip and multiply, right? So let's do that first. Okay, so divide means flip and multiply, mean flip the second one. So we've got x squared, it stays the same, x squared plus 6x plus 8 divided by x squared minus 16 times, flip that one, x squared minus 9, x squared minus 7x plus 12. Okay? All right. Now we can do what we did on the example above. Factor. Factor all these. So we've got x, a trinomial, two binomials, x and x, 8 with 6 in the middle, so that's 4 and 2. So like we just did that one, didn't we? X squared minus 16, difference of squares, so x and x minus 16, so that's minus 4 plus 4. It's going to work out nicely there. Do the same thing over here on the right, x squared minus 9, so that's x minus 3, x plus 3. And then x squared minus 7x plus 12. X and x, 12 with negative 7 in the middle, so they're both negative. Be negative 4 and negative 3 for the factoring there. So that's kind of the hard part, because once you got that, then you just start canceling. You got x plus 4, cancel those out, top and bottom. What else? We got x minus 3, x minus 3. You cancel those out. And I believe that's it, because again, can't cancel that at all, because x plus 2 can only cancel factors that are exactly alike, binomial factors, so those aren't exactly alike. That's it. We've got x plus 2 times x plus 3 on the top left. And then, now, on this one we got a choice. We've got x minus 4 times x minus 4, but we could write that as x minus 4 squared, just to make it more compact, I guess. If you wrote x minus 4 times x minus 4, that would be okay, but is that okay? All right, so yeah, that's multiplying and dividing. That's what you do. Cancel common factors and see how it reduces.